Hey, folks, welcome to Learn Live and
Hello.
to the final episode of microservices, episode on microservices, by the way. And I'm Vivek Sridhar, cloud advocate from Microsoft. I have Mihaela with me. Hey, Mihaela, how are you?
Hello.
Please,
Very happy to be with you here today.
perfect. And please introduce yourself to the audience.
Well, I'm a technical lead for Strong Bytes and Microsoft MVP, which stands for Most Valuable Professional in Developer Technologies. And I'm saying hello from Romania. So, really nice to be with you here today.
Same here, Mahela. Thanks for joining in. And we have Arish, who is moderating today. We are live, by the way, and that means you can ask questions to us. And Arish is here. Welcome, Arish, for the show. And say
Hi.
hi to Arish. And please do ask questions to her. She's an expert, and while we are doing this Learn module live, while we're executing this Learn module live, um, Irish is in the background answering your questions. We will also take a couple of questions as well, but do make sure that you post questions to her, and she will answer you all the questions. And she's an expert, so say hi to her. Welcome once again, Irish, to the show. And from today's Learn module, what are we executing? So today we are going to learn GitHub Actions from a microservice perspective. And that's the QR code, and that's the link to the Learn module. And we are going to execute this Learn module live in just few minutes. If you want to follow along, just take that link and you can execute it with us, or sit back, have some coffee, listen to what we are going to say, and you can take that QR code or the link after this session and execute yourself as well. So, going back, so Mahela, I just wanted to understand what we are going to do today in depth. So I just introduced, what we're doing, at a high level. So why don't you go in depth on this?
Okay, so basically today we are just going to wrap up a lot of the things that we've did in this module, and we are going to discuss about GitHub Actions and how exactly are we going to um, create a build, create a deployment, see what is happening in there. So more exactly, we are going to discuss about authenticating GitHub Actions to a container registry. Basically, we are just going to see exactly how we can use Azure Active Directory Service principle to allow access to GitHub. So we'll see exactly how we can connect in there. Then we are going to learn a bit about how to securely store sensitive information used by the GitHub Actions. So we are going to see exactly that we have to put sensitive information in, we have to encrypt it. Uh, we are going to discuss about secrets, yeah, and where exactly is that secure location where we should keep that data. Then we are going to implement a GitHub action to build a container image for a microservice. Yeah, we are going to see exactly how we are going to build it. We are going to go step by step to see exactly in the file that we are creating and why we are creating it with a certain structure. Then we are going to modify and commit the microservice code to trigger a build. So we are going to see in there that we can trigger by doing certain actions build. So we are going to learn also a lot about this part. Then we are going to implement a GitHub action to deploy a container to a Kubernetes cluster. So again, we are going to look a bit on how we are going to create that file, what we have to take into consideration. We are going to learn about the components of GitHub actions and how we can use it in a deploy file. Then we are going to modify and commit a Helm chart to trigger a deployment. So as we did in the build part, we trigger the build. So we are going to do it for the deployment part. And last but not least, we are going to just see how we can reverse the microservice to a previous deployment. Let's say that maybe during production, some issue appears. So we have to see exactly how we can revert certain deployment and how we can reuse one that is stable and have everything good to go as efficiently as possible. So this is pretty much what we are aiming to do today. So stay with us.
Yes, and it's interesting to see this because it's not just the DevOps workflow which we are going to do. We're going to show you how you can deliver this through a complete developer workflow as well, right? So let me take a step back and um, you know think about DevOps as a whole process, right? So DevOps is about getting the feedback from the code, right? A developer pushes the code to the repository, and he will be able to get the in fact, he'll be able to get back the feedback as soon as he pushes the code to the repository, and that is what DevOps is all about. And from the business use case as well, you're supposed to I think we just okay. Am I in the background? Okay, there's some issue. Okay, fine. So it's about DevOps, right? So basically, there is a developer pushing the code to the repository, and from the repository, you're getting the feedback because you're running a couple of build, check-in process and other things. So you're doing a CI process and other things. So why do we need to build this? So it's very important from development perspective, because the feedback you're getting from not just from the users, but also from the code. So the code which gets pushed in should get the feedback immediately to the developer, right? So that is what we are trying to do now. And basically, what I want to talk about is the previous example which we have taken, right? So there is eShop on containers. There is bit of microservices we have, and these services can have developers, and these developers are coding on different services. Say for example, coupon service which we have, and on the coupon service we have developers pushing the code, and we might have 2 to 3 developers pushing the code. They might introduce two to three things. One is they might introduce bug, and they might add a new feature which can break the feature which is already running, and all these things can come into the coupon service. So that's the issue, right? And you need to build an automated way to get the feedback of the code. So developer pushes the code to coupon service, and he gets the feedback of the code as soon as he pushes the code. And the feedback is driven through various processes which we will talk about it. But that's the net discussion here is how does a couple of developers pushing the code, and how do they get back the feedback, and then they go back and solve this problem, not just from the developer perspective, from also business perspective, how users can also send in the feedback to the developer. And it has to be really fast from a DevOps perspective, right? And so we are going to use a couple of DevOps workflows for this. And so Mihela, just wanted to understand the continuous integration and continuous deployment. What is it, and how does this help in a DevOps workflow, and how this is been done, and why it is required?
Well, actually, I'm glad that you mentioned the fact that it's not only about DevOps, but it's also about the team, the development team, and the processes that we have in the team when we are writing code, and until the code gets actually into, the production part. So it's good to actually, before discussing about the actions exactly that we are going to do as we have planned, it's good to discuss about the approach. And when having here two main things that I would like to approach, and one is the continuous integration, which is a process of automating the build and the testing of code every time a team member commits changes to a version control tool we're using. So basically, developers continuously integrate their code. That's why it's named continuous integration. And this code is checked through a series of automated steps. Besides the building itself of the code, you can also do some testing, validate the code through some coding guidelines. Yeah, you can do some checks in there, maybe some security checks for your packages that you're using, and so on. Then, when everything is checked and everything is green, we can merge it into the code base, into the shared code base in a more controllable way and easily than if you would be doing these changes, manually. So the automated steps that we've mentioned are triggered by simply committing code, or if you have an option for this also after a pull request is approved. Yeah, it's important again to do a check before the code is finally merged. So as a result, that automatic build starts, takes care of all the validations that we've discussed, and then just takes the code in the desired branch. So continuous integration appeared as a way to help developers work in isolation, not depending on the changes that others do, and without actually impacting the work of others. So basically, using continuous integration, we can integrate our work as efficiently as possible in the main code base when we know when we've finished all the checks. So in time, this actually became more than a process. It became a best practice, because besides the good organization within the team, it also brought essential advantages on, integrating the bug fixes, merging branches, which took a lot of time. Doing that manually is not fun, and not doing it, I don't know, after a long time. Then you can also think about creating some strategy for some hot fixing that you might have at some point. So this approach is easy to incorporate in the whole version control approach, because it helps software developers isolate that work and then just push that branch, that feature branch that they have, into the main branch, or depending on the branching strategy that they have. So
True.
yeah, long
So
story
my
short, it's a good practice on.
Yeah.
Um,
So what I have to say is, in this example as well. So we have a coupon service, and we have three developers who are pushing code to this coupon service, and then two developers make changes. They push the code. It gets integrated automatically on your GitHub repo. They push it to the CI branch, and then it gives back the feedback to both the developers how exactly this particular code is, whether it is good to go, or it is, we need to do a merge, or there is need to be a we need to fix something with respect to the test which has run and other things. So the developers are getting feedback immediately. So that is what continuous integration does, right, Mela?
Yep, and I think it's good to also mention the fact that we can add all sorts of branching policies in
Yep.
order for us to
Yep.
control the pull request that we are going to create. So it's a lot of let's say control also in that part. So we are not that exposed to making errors, but more like gaining a lot of time when it comes to issues that normally appear later in the process and are harder to overcome.
Correct. And by the way, if you want more details on continuous integration, there's a link below. You can go to that link and read through it, and it's pretty good documentation of what is continuous integration is. So this is continuous integration. So basically, we're integrating the code, and we're seeing how exactly this code behaves from a integration perspective. So there is also, after integrating, we need to deploy it, right? So how does that work, Mela?
Well, they work very good together, because continuous delivery basically is the process of building, testing, configuring, and deploying from a build, what we've discussed, to the production environment. So simply put, we take a production ready result, if we can name it like this, from the CI and pass it through the pipeline through several settings and validation processes. It's as a good practice, it's good to take into consideration that it's safer if you have multiple testing and staging environments when you're creating this pipeline, in order to check that through several cases, maybe do some multiple types of testing, security testing or some automation testing. So you want to check that your environments are as healthy as possible, and that you don't have any issue along the way um, with the little product that you are trying to in the end get to production. So without the continuous delivery, software release cycles used to take a lot of time, and also be exposed to a lot of errors. Since we are doing this manually, we are exposed to human error. So it's understandable. It's not something that we cannot work with. But if we have a possibility to actually automate a process and do all the flow more efficient, why not? So basically, continuous delivery is a lean practice to keep the production as fresh as possible, and doing this delivery itself in a very efficient way, and gaining a lot of time also on the process.
True. And by the way, it's basically it's basically you're controlling the deployment as well. So whenever the code is being pushed to different environments, when it comes to the production environment, you control the deployment of that code to production environment, specifically since it is continuous delivery. And some people will have questions on what is the difference between continuous delivery versus continuous deployment, right? So we will see that in next slide as well, how continuous deployment versus continuous delivery fits in. And obviously we have the build, and we take that build and deploy it to production, and that process is called continuous delivery. So I'm going to we will spend some time on understanding how this completely works. So Mihal, so can you just explain how this completely work in real world scenario?
Well, actually, this is a very good example of how the whole process is working. If we can, just look at the control that we are going to have. So it's also a lot. Maybe before starting to implement a process like this, it's good to check maybe some best practices, see exactly if it's or how complex should it be for your product. As in, if you have a very straightforward application, or if you have a more complex one, if you have maybe some microservices that you're working with, you have several steps in testing and so on. So it's good to also take into consideration that the whole process works continuously from integration to uh, delivery in the end. What I wanted to ask you, Vivek, is since we are discussing about the best practices and approaches, what is your perspective on this from the experiences that you've had along the way?
Yeah, so in my previous organizations, I happened to build the complete CI/CD for enterprise and for startups. So I worked in both of these two different industries, right? So from a enterprise perspective, if you see that there is when a DevOps when a developer check in the code into the source control. We used to trigger these builds and unit tests and other things, and automatically the result were made available to all the developers, and we could easily see what code was having an issue, and who created that issue from a developer perspective, and he or she would fix the code. And as you see that these specific tests like automated acceptance test or user test and perform pre-production, all of these had different environment altogether. So we had different environments, and code was going into from one environment to another environment. And we were using the artifacts where these build were created and stored, and we were processing these artifacts from one environment to another environment. All these things were done through automated way, right? And as you can see, there is a lot of loops in terms of getting feedbacks. So as soon as there is a issue in one of the environment, we used to stop the next process. There is no point in going to the next set of tests, because we know it has failed and we don't have to go back. So this is from a enterprise, right? So if you go to the acceptance test and release management, release is nothing but production here. So if you see that there is approvals, so there is an approval required to process these builds, to process these code to the next set of environments. So that is where I was talking about the continuous delivery part. And then continue when it comes to startup, these everything was the same, but there was continuous deployment strategy. That means there was nobody was sitting there and approving these code. As soon as everything is green, the code used to go to the production without anybody sitting there and approving stuff. And also you can see that in a obviously when we were doing it in startup, there were the code which was coming in were like we were doing it like every 30 minutes. So every 30 minutes we used to have the either different build where gets to trigger. And code was, as soon as the developer is checking in the code was going to the production. So that's the kind of process we need to build. That's the kind of automation we had built. So that's where the CI/CD comes into picture from a agile perspective. And to do that, we definitely need different platforms. One of the platform used in today's example is GitHub Actions. So Mahela, can you just introduce GitHub Actions to our audience as well?
Sure. Well, as we discussed these two processes, it's safe to go a bit into more details regarding how we are going to do this. So we are going to discuss about the platform that allows us to automate everything that we've mentioned before. And we are talking about GitHub Actions. Well, using GitHub Actions, we can create both build and test workflow for the CI, but also uh, workflows that help us deploy merged pull requests to production. So GitHub Actions goes beyond just the DevOps approach and lets you run workflows when other events happen in your repository. And since we are discussing about running some workflows, we are going to also go a bit more into details what those workflows are, and we are going to implement some workflows today. But it's important to note a bit on how we are going to run that and where exactly. Well, GitHub provides Linux, Windows, Mac, virtual machines for doing this. But you can also have the freedom to just use your self-hosted runners in your own data center, or I don't know, some cloud infrastructure if you have. So things are very, very open in there. And I think that in order to maybe explain a bit what these actions actually are in the big scheme of creating those workflows that we are discussing, I'm just going to uh, let you maybe tell us a bit about these components.
Yes.
What are they
So
exactly? How they are relating?
definitely. And by the way, GitHub Actions, what we have is DevOps workflow, but it does not necessarily have to be from a DevOps workflow perspective. It can be for any of the developer workflow, to automate any of the developer workflow. Basically, it's a platform to automate stuff. And this is a component. So basically, it's always triggered through an event. So there has to be an event. It could be either a developer is pushing the code on the main branch or any of the branches, or it could be a issue being created, or it could be a new contributor joining the your GitHub repository to deliver code. And you can see there are different runners. So as Mihela mentioned, right, so runners are nothing but the infrastructure. To run any script, you need an infrastructure. To run anything, you need infrastructure. If you want to run a container, you need a infrastructure. So that is where the runner comes in. So GitHub provides you the infrastructure to execute jobs. So job is a set of steps. So if you see in this diagram as well, you can see there are a couple of steps which is there. So you take these steps and you execute it as a job, and you have the runner, which is an infrastructure which is running. And you can have multiple jobs with different runners as well. And that's the unique part about GitHub Actions. So let's see an example, right? So how this workflow really works. And this is a simple example. You can see that there is the name of the workflow, which is learn GitHub Actions. And there is an event which is happening, that is, so a developer has pushed a code onto the onto the some of the branch, and we are taking a simple main branch which is on push. And you can see the runner which is mentioned as Ubuntu latest. So basically, it is running it on Ubuntu. As Mihela mentioned, it also provides you Windows and Mac OS as well for you to run your jobs. So this is for this particular example, we are taking Ubuntu. And you can see, it is running a job. So the job is to just verify the version of the batch script, which is the compilation script which is there. So we are running couple of steps. So one of the step is to actions checkout and action setup node. So this is what is this users mean is, there is already custom built applications which is already available on GitHub platform, where it's basically the application is already ready for you to use, and you don't have to rewrite this code. So there is a checkout process which is already been written, and I will show you how exactly you can see these each of these actions, and how you can see the parameters which you need to give for this particular actions. But for this particular example, just take that there is a set of things which is already pre-built for you, and you are just using it in your script. And you use it for installing Node.js. And there are multiple things, like it's there for Terraform, it's there for Azure, it's there for Docker. And then you run couple of commands which you normally run for installing npm package, and then you check the version of that particular package. So basically, a simple key value pair script which is running in, and you're setting up that script, and you're just pushing that script to the GitHub repo which you have, and then just execute it. So we will anyways build it while we are while we are running this particular learn module. But this is how you can visualize it. So, Behela, yes, GitHub Actions are there. There is also Azure pipelines. What is the difference?
Well, actually, both are a valid way of creating this kind of workflows that you've just mentioned. They help us automate some steps, as in the building part, testing, publishing, release, and so on. So they both have kind of the same objective in the end. What we have to maybe take into consideration are some details. For example, let's say that when we are discussing about Azure pipelines, we have that interface that helps us a lot when we have to define some configuration in our workflow. Instead of just creating some YAML file, they're just allowing us to work with something more friendly, easier to watch. GitHub Actions, on the other part uses the files to create the workflow, so they don't have something as a graphical editor. For example, in the beginning, for someone that is doing this for the first time, it might be easier to understand and see, the steps, visualize the steps, and it would be easier to understand how you create that continuous integration configuration in Azure pipelines in comparison to GitHub. So maybe this is something that can be a difference. Then we can discuss about the fact that Azure pipelines are somehow not that strictly on the structure of what we are building, of the configuration. You can have only one job, so that's it's okay. You can work only with a job. Well, for GitHub Actions, you need some explicit configuration. Yeah, that structure that we are discussing in the files that cannot really be omitted. When you are working with that editor in Azure pipelines, it's easier to just drag and drop things and work with that. But again, if you are more experienced, or if you have experience with using YAML files, well, it might be easier and should be no problem. So this is something maybe of preference. Then we discuss about staging, stages that we are using into the file. We can create, of course, deployment workflows using those stages. Well, in the GitHub Actions, you have to separate those stages in different YAML or workflow files. As in, I'm creating a deployment, I can link them, and go through from one to another and just have it working very nicely. Well, when we are discussing about GitHub Actions, we have to create those files for each. Last, maybe it should be important to know the fact that GitHub Actions have those self-hosted runners that can be selected with some labels. And on Azure pipelines, on premises, you can use some build agents with some certain capabilities. So as you can see, the differences are not that big, because you can reuse a lot of steps, tasks. Yeah, you can create some tasks that are generic and then reuse them. For both, you can write your configuration in YAML files, so it's not, as I was saying, it's just a preference of using the interface. So they are not that different. Maybe it's just a matter of the tool that we've used until some point, or maybe some preferences when it comes to the maturity of the team, maybe.
Yeah, true. So, so basically, I mean, one against the other. Basically, you can use GitHub Actions, where you might want to go full on with a lot of controls as well, with because you have the GitHub repo already, and you're using the GitHub, and you just can directly use GitHub Actions with your GitHub repo, making it more of a GitOps kind of a thing. And from an Azure pipeline perspective, you have you probably use it with other code repositories as well. So that is one of the thing which you can do. And obviously, as you mentioned, the on premises support and other things which is already there. There are different use cases, and it could be an enterprise and startup. Various things can be built in. So I'll just move on, keeping the time. So we have exercises, Mela. So we have four different things which we are doing. We are setting up the environment, which we already have, just for to make sure that we are ready for executing rest of the things. And we will anyways talk about that, and then we are going to configure GitHub Actions. Then we are going to work with building the container image and deploy to Azure Kubernetes Service as well. So let me go to the exercises. Let's go and execute this learn module. um, this is the learn module which we are executing today. um, so you can see here we are using eShop on container app, and the most important thing about this particular learn module is that you will have to fork the repository which is here. So you just have to open this repository, which is a GitHub repository, and just go into that GitHub repository and click on fork, and you'll be able to fork it into your repositories. You can fork it into your own code, right? You can create your own code base repository, in fact, in GitHub. So basically this is how it gets created. This is my same repository from a fork repository, right? So that's what it is. So um, I've just run this magic script. So this magic script actually creates a lot of things. It installs required version of .NET. It clones this particular app, and goes on to provision that app into Azure Kubernetes Service and container registry, and launches a Cloud Shell, and usually deploys the code, everything onto the Azure Kubernetes Service, and you're ready to go. So this is what it has deployed as of now, and we will obviously go and see what it has deployed. We will try and buy some stuff for ourselves as well. So let's see. Um, so this is the demo. Let me log in to this particular. So this is the eShop which we are talking about. This has microservices which we have. So let me buy a hoodie for myself, um, and there is a two hoodies which I just got. Okay, so let me go and use checkout, and we already have the coupon service. So if you have missed the session on how did we add coupon service to this particular code base, check out the previous versions, previous videos which we have on this specific topic. So I can just go here and place order now, and you know this is what it does. It creates the order and places the order and everything. So basically this is what we have now. So what we are going to do now is to configure GitHub Actions for making changes, building an automated way of pushing code to Azure Kubernetes Service and other things. So we have seen this. So basically it also have health check. We also did a lot of sessions on health check and sec as well, which is also a dashboard to show you all the logs which is coming in. So it's an interesting session. Please go and watch it from a previous perspective. So this is what we're going to do now. So Mihala, why we need to do this?
Well, we are discussing Azure and we are discussing GitHub. So in order for them to actually collaborate, and work with some artifacts in the area, use some data, we need some permissions. So we are trying to do this as safely as possible by using an Azure service principal. So this is exactly what we are going to do right now. Just as a mention, an Azure service principal is a type of identity that we can use with applications that actually help us to automatically access Azure resources. So this kind of setup is exactly what we are going to do in this, just to see exactly how we can create this link between the two. So first we are going
Yes.
to run the command.
Yes, this is the command.
In order to create that Azure Active Directory service principal, in order to access those resources from GitHub. After we are running this command, we are going to just get some data For each of us, the data will be different. But the important thing is to actually copy the information that we have in the JSON format and create the secrets. So right now, Vivek is showing us how to create the secrets. Basically, we are using the naming conventions that we have for those secrets. And we are just placing the information that we have in the JSON format in there and creating the secret in
Yes.
the end.
So what I've been doing is so basically into my repo, going into the settings, and under the settings there is a security and there is actions. And when I click on the actions, I can create a new repository environment variable. And when I do that, I can just give the name, and I'm copying only the JSON output of the command. So you don't need to copy all of these things. You need to make sure that you copy the only the JSON output, and I'm just copying the JSON output of the command and I'm adding the secret here. So that's been added, and you can see that I cannot see what is the secret here. I just need added. I can update it, I can remove it, but I cannot see it anymore. So that's what Azure Credentials is for. And we have created Azure Credentials to connect to the GitHub and Azure to be connected using valid identity management, right? And now we have added the secret. Once we have added the secret, we just go and add a couple of more secrets. So to add a couple of more secrets, you can just go and cat this specific command. You can see this is what we need to add. So let me go back and add these ones as well. So this is how you can add it. So it's basically IP address. I need to add, what is the IP address? 40 dot something.
It might take a bit of
Actions.
time, but since it's sensitive information, it's worth the the trouble to
Yes.
just be sure that everything it's safe. Especially since we need these credentials in order to interact with the Azure Container Registry, the Azure Kubernetes Service. So it's a lot of sensitive data in there. We have to be careful.
So I'm just adding the username, passwords, and a lot of important stuff. Uh, so I've become good at copy pasting.
It's part of developers' work, right?
Yes. So I am adding this. Is the skill you have to keep practicing. Yep. So we have all the secrets. These are the secrets which we needed, and we have updated it. All we have done is just run one command, and rest of the things are already there. So it is being created in this config file. So that is what we are picking, and we have created the secret now. Now we are going to do what we're going to do is go and create a GitHub Actions to build a container image. So we need to make changes to the code to get to build done and other things. So so while I'm going to do this, so Mayala, you can just explain them what is actions and how this works. But while I'll just set it up first.
Okay, so basically what we are going to do is create some actions in our repositories in order to be able to set up those workflows that we were just discussing some minutes ago. This is a very easy action to do, let's say. We're just going to go into the Action tab, yeah, in the repository. We have it there. And in there, we are going to, after we click it, we are going to see that we have an option to set up a workflow yourself. After we're doing that, immediately we will have a placeholder, yeah, file with some information, maybe some placeholder info for a workflow. We are going to replace the information that we have with the setup that we have for our module. And we are going to see a bit that maybe it's important to see that this build is going to be triggered only in the moment when we have either changes in the coupon part, in the services, or in the test, discussing about coupons. So we can configure exactly for the build to be triggered actually for a certain location. Then it's important to see that we are triggering it at push. So this is automatically run. After that, we have some jobs that we are going to define. Build and push Docker image. You can see in there some steps. What exactly is using and what is the reference, which is the main branch. The very important is the fact that this is automatically getting the code from the repository, so we don't have to do anything manually. Then we are running the unit tests. Again, also for this we have, as you can see, we are running exactly the project that we have for the unit tests. And then we are just going to build and push the Docker image. This is the place where we are using some of the secrets that we've defined before. So as you can see, we are just accessing those secrets by writing secret dot the name of the secret that we have, and we are just going to access the value that each of them has. After we do this, maybe we can just see exactly what happens after we trigger it, or how do exactly we trigger it. What it's important to note is after we are sure that everything is in place, we have that green button in there with start to commit. But before this, don't forget to change the name of the file, because in the beginning, when you created that template, you had also a placeholder name. So it's important to name your files. As we are discussing, we might have different files for different operations that we want to do. So it's important to keep them named accordingly. So after I'm sure that everything is fine, I'm just going to commit my changes and see what is happening.
Before we do that, I just want to show you how exactly this works. uh, we are using this actions, and you can have your own custom actions, or there is already custom code which is already there. So if you go and you just copy this action, and if you go to github.com and slash this actions slash checkout, right? So you can see that there will be a file which is called actions.yaml, and this is where it talks about the format of this particular actions. So it is already pre-built. It is already having all the default things which is required. It will also talk about what other things it is going to use, and other things, and it is also mentioned here some of them are true, that means it requires this while executing it. Some of them are false and other things. So it's so any action you see, you can just copy and say, for example, if you are looking at Docker actions, so if you just go here and do the same thing, and you just run this, so you will see the actions.yaml, and it has all the defined what are the inputs it takes in, and what are the things are required or not, is this required or not, everything is available here. So this is how you can use this pre-built ones, how to use pre-built ones. This is how you can use it. Okay, so let me go back to the code. So I have made those changes, Mihala, the build.yaml. I've added the code, everything is done. I'll just do a start commit, create the build, commit to the main branch. I can say uh, adding new GitHub
Maybe sometimes
actions.
it's something that we overlook. It's just a comment to a commit that I'm doing, where it's important because you don't know when you have to roll back some changes. So you have to pay attention to maybe make some guidelines also for this, how you're going to name your commits, how explicit you want to be in those.
The moment you create this, it's still not going to run because we haven't made any changes to the code, right? So we need
Yes.
to go back and make changes to the code. So what we will do is we will take this source service coupon service, and we go to this controller and make some changes to it. Okay, so we can go do it directly on my code base. So we'll go there, we'll go to source, we go to services, we go to coupon service API, we go to controller, go to this.
Maybe it's important to just note that the reason why nothing happened after we committed that file is the fact that in the file itself, we had that condition that the build will be run at push when we are doing changes either in the tests, in the coupon, or in the service itself. So since we did no changes in there, the build was not triggered out of nowhere. So this is what we are doing now, actually, changing
Yes,
the
I'm just
controller.
made changes. I've just made changes in the controller and just pushing this. And the moment I push this, what happens in the action? Let's see. Oh wow, it's running.
Yay.
So we go there. So we're gonna see some failures. We're gonna see some failures. Yes. So you see here, .NET test would fail when it tries to run a unit test. Um, it's going to run some of the tests, and it tries to run it, and it fails because we have not enabled it. So that's the reason why it is failing.
The good part is that we have logs with which test it's failing. So we will see exactly why is that failing. So basically, we have a wrong assert in there for one of our unit tests that we are going to
So what we're going to do now is
change.
we monitored it, we saw that there is an issue. We go to this coupon test. So we go to
Yes.
test it out, controller test, right? So that's where we have to go. So let me go to my code base and go to test service coupon and controller test. So we're going to edit this. We're going to make this true.
Of course, this is not a real test. It's not testing functionality. It's just something that we needed in order to show exactly how this works. What is very interesting, Vivek, and I would like to uh, go a bit into the previous build. No. In the update coupon controller, it's important to note that in the previous build, the step after the run unit test, so the one that is building the Docker, pushing the Docker image, was skipped. So basically, if something fails, we can create, this sort of dependencies between them in order to not, deliver code that is failing, that has errors and so on.
Yes, and by the way, you can also see this interesting one is because let me go to the code, the GitHub workflow. Um, we were able to, the GitHub Actions are workflow is running only because we have set the path only for test and only for coupons. So we made changes only in these two code base. That is the main reason why these actions are also running. So if I make a change in any other service, these actions won't run. So that's the importance of how customizable these actions are. That is the thing to note here. And if you see this, it's running as of now. And also you can see it is, if you see this couple of things, we can see basically it sets up the environment. It basically uh, it checks all the actions before it gets started. So that means if you see here, in our code base, in our actions YAML, we have already given actions checkout and Docker build action. So it verifies whether uh, it is already there or not. It fails here only if it is not there. So you're making sure that this particular already pre-built actions are already available, and then you go and execute the pull request, the code. um, it checks, it is using this repository. It is creating a clone of this and then using it for execution. So that's what it does. So it's running the test. It is done. It is done and tested. Now it's already completed it. So we are good to go. It's green. So we have done the build, right? So
Yay,
um,
successful.
so it's so good, no? Like as a developer, if you see this green, like, yeah, I'm done. So that's what we
Coffee
do.
break.
So coffee break. So so yeah, so basically we have done the fix, and we were able to execute it, and you can see it build is done, and it has pushed this particular file um, to the repository, the Azure Container Registry, right? But now it is just about building it. So we have packaged it, and we have hosted the package, but now we have to go back and see how we can deploy this particular package to uh, Azure Kubernetes Service, right? So similar to what we did in the previous step, we create a new workflow. I'll show you how. Again, we're going to create a new workflow here. Let me go back to this and go back to actions, and here is where new workflow is. Just click on the new workflow and set up workflow yourself. By the way, you can also choose different workflows. Okay, so basically you have already pre-built workflows for various things, all developed by the community, so you can go and pick it up, or there are a couple of GitHub specific ones as well, so you can also do that. So as of now, we are doing a setup of our own, so we are doing that, and we are calling this workflow as, we cancel this change. I did a today. Let me go back to actions, new workflow, set up a workflow, and call this as uh, deploy
Deploy.
deploy workflow, and we're going to copy the code which was there. We copied. So in this, in this specific, let me preview this and show you. So in this specific one, there is name, and you can see this. It's on push. Again, we are using path. So this is specifically we are doing the Helm chart. Any changes made to the coupon Helm, we are going to make sure that this particular code gets built. And this is the jobs which is running. We are running, and this job is to deploy to Azure Kubernetes Service, and it is using Ubuntu. You can use different systems as well, and you can basically different OS. You can run these workflows in all the three environments as well, using Matrix as one of the key. So that is one way, and you can notice this. There is already pre-built actions, right? So if I go to again, if I go to github.com and copy it, add Azure aka set context. So here is where you can go here and see actions. So you can see it is already having couple of things. What is required input? It requires a resource group name, it requires cluster name, and also this is the code to run it. So basically it is already asking us to provide all these details to run this specific action, pre-built action. So if you see this, it's very simple, and you are using credentials. You're providing resource group name, cluster name, which is with these things, and the name is here. Again, we are using the similar one. Again, there is Azure Helms Helm setup, which is already available. Same thing with login, which is already available, and you're providing with credentials, and then you're just deploying with the command. And this is the command to deploy. So we have just also we had, if you remember, if we had also created the secret registry login server details as well. So that is what we are using, and and these are the things as well, the IP address and other things which was already set. So simple key pair values setup, and it is um, these are the steps which we are going to do from a execution perspective. So let me just go back and commit this. We're going to commit directly to the main branch. So let me go and commit. I'm gonna deploy to Azure Kubernetes Service, and commit it. It's still not going to run. Um Action, if you go to action, it's not running. The only reason why it is not running, because we haven't made any uh, changes to the Helm, right? So we just go and make changes to the Helms. So we had made changes to the code, right? We added log details before we build the coupon service, and once we added the log details, we are making it as our next version. So let us go back and add this version. We are going to update the version from whatever version it is. So we'll just go to the code. We go to code. Which code is that? Deploy case,
Diplom, Helm,
simple
coupon
coupons and charts, and we'll say app version. Oh, okay, I need to edit it. We're going to say
1.10.
1.1.10, right? So I'm going to make these changes, and I'm going to commit updated chart, and directly committing on the main branch, and you'll see actions running. So you see here, we have actions. GitHub Actions are running. The workflow is running basically um, through GitHub Action platform. So you can also see a couple of things here, right? The commit, what are these commit messages as well? So if there are a bunch of commits which is happening, you can also see for each build what is the code which has gone in. So it is available here. So it's pretty easy to track this particular changes you are making in the code. So let me go here. As I told you, well, it was pretty fast. So as I told you, it verifies whether all those things which we are using as part of the use is available or not. Is it right or not? So it basically downloads this repository, checks the checksum and everything, and then it starts with the rest of the things. So it is doing the execution is happened and it has deployed. So let us go back to health check and make it 1 second, and change. Is there anything? Okay, so we have this code base as well. So now we go back to this, and we will see how this code has changed. Let me copy this and show you how this coupon service is setting up. So what we did was we upgraded the system, right? So basically, if you get pod on this coupon service and watch it, you will see that one is running, the other one got created, and it is 87 seconds. And if you remember, the previous sessions we did, if you're attending this for the second time, we did talk about liveness and readiness, right? So this particular pod is not yet ready to be used, so it is still it's still this one is still executing. So that is what and happens in Kubernetes, right? So basically the one it is running, and now you see this one is in ready state. So it got enabled, and it is the request can be sent to this particular pod. Hence the old pod which was there is getting terminated, so it's got terminated from that. So that is what is happening here. And if you see the sorry, so one more command which is pretty interesting to see is the history of changes we have made in Helm, right? So if you go to, oops, I copied the wrong one. Let me copy
Uh,
the,
7.
yep.
Mhm.
See, as I told you, it's a skill. So um, so if you see here, right, so this is the app version. So basically this is the app version, right? So this is what happening, right? Yeah, Mahela. So basically what is happening is the previous one, it's got suspended. In the new version was introduced in the app version, and we will see in the code as well, we will see as per user experience as well. So we will log in, and we will again do a, you know we will buy hoodies for ourselves
Oh,
and see how it works, right? So we will go here, we'll buy hoodie, and also buy some stuff, not
I
just
like
hoodie.
shopping, so let's do it.
All we need is a credit card.
Yeah, and the discount, which we
And the
have a
discount.
discount code.
Yes. So we have all the ingredients to test this one. So we do have discount 5, and we apply that, and we go and place order, and you can see the order has been placed, and you can see that this particular status keeps changing, and that's what we're going to see so for some time. So let it go. So it's getting updated, stock is getting validated. It will also go and validate the coupon. uh, Once it validates the coupon is getting validated. We have been validated. It has to come to the status where it is paid to complete the order. So it is still validating couple of things, and it is paid,
Yay.
so we are done. So the good part is we have executed this. So basically we will go and see how this works in, that we added code to see the logs. Basically in one of the exercise, if you remember in the previous exercise, uh, we added a code.
In
Let
order
me
to
show you.
trigger the build, right?
Yes, this one. So this was added to make sure that whenever you're applying code, log these information. And if you go back here and see whether that code got really executed, so we will see there is apply coupon discount 5. So if you see it is logging information for us, right? Retrace ID, span ID, all of these things getting logged uh, because the new code was introduced. So if I remove that code, this won't be shown. So this is how you can build and deploy. There is what we did now is we completely automated the execution. So what we did is we took a piece of code, made changes to the code, and it went on to build that code, and then we were able to deploy that code. We can also make, connect these workflows as well. So we can connect it in a way that execution one after the other. So once the build is done, go and deploy it. So we can also connect such workflow as well. And obviously when it comes to production and setting it up in for the production, you need to build a strategy around it, how exactly the code should go into the production, and what are the things you need to transit from one environment to another environment, how it is transiting, and other things, right? So all these things need to be taken care. um, so I'm going back to the exercise which we were executing. So let me come here. So what we did is basically to show you history again. So it's already running there. So uh, we have this app version currently deployed. So how do we go back to the version which which is which we want? Like we found that this particular version is not really a good one, and we just need to revert back the changes and go back to this particular version. How do we do that in Helm? Right. So basically, what we're going to do is we're going to just run a simple command. It's called rollback. So once you run the rollback, it's all done. So once you run the rollback, it's basically the code gets rolled back. And if you see, run this, and you can see here my app
All the
version is
changes.
1. All the changes is rolled back, right? So this is how you can do the rollback as well, and simple rollback. So let's go back to the slides. We have what we have done now is basically created the permissions, added it in the settings, the secrets and other things, and we build it and deployed it to Azure Container Registry, and we did build it and deploy it to Azure Kubernetes Service as well. Uh, we built the complete workflow for that. But whenever you are using all this stuff, make sure you clean up all this stuff as well. That's very important. And we are into the important part of the in discussion, right? So basically knowledge check. So we're going to run couple of things. Basically you will have a link and QR code. This is the link to oat, and this is the QR code which where you can oat. And I'll give you 30 seconds to go to this specific link, and also you can use the QR code to go to this link. There's the same. Just go there, and you can basically vote for this specific question. So the first question is on basically without using GitHub Actions marketplace, where should sensitive information such as credentials be stored for actions? So, what do you think, Mayla? Like for this?
It's a tough one, but I'm thinking let's take them step by step and see maybe if we manage to give the right answer. So basically, we have the app settings JSON. This is something of a file where we have some configuration, as database connections, any application. I don't know, variables that are global. So it doesn't sound to me a place that's safe. Then we have the web config. Well, web config is more used in the area of IIS, yeah, using it with .NET-core. So basically, we are using it to configure an app hosted with IIS. So again, that doesn't really seem to be like the the right option. Then we have the Azure Key Vault. Yes, it's helping us with the, using some keys and some secrets used by cloud apps and services. And then we have the GitHub secrets. So we were mentioning, okay, the Azure Key Vault is uh, about sensitive information, but we were talking about GitHub Actions marketplace. So we have the last option, which is the GitHub secrets, and in here, as we use today, we can store sensitive information in those secrets that we did before. So
Yeah, I think the answer is the GitHub secrets, and whoever got it right, amazing. Let's go to the next question. Um, you need to take some time to read this because it's quite a bit of text. So what is the purpose of creating an Azure Active Directory service, service principle for use in GitHub Actions? So there are quite a bit of interesting options there, and it's going to confuse you. Just take some time to read through this before you answer this question. Um, so, what are your thoughts, Mela, on this question?
Hmm. I'm just thinking about what we've discussed before. I have something in memory related to the fact that we run some command in order to get a JSON structure at some time. So I'm just thinking that the answer might be behind uh, this information. Why did we do that, and how exactly? What we are trying to connect in there? What we are trying to get data from where? And I think this is where we have the answer. So I'm thinking that maybe it's C.
Yes, and the reason is because we are trying to connect to Azure. So basically, the question is, how do we, you know, why we are creating the Azure Active Directory Service principle is because we want GitHub to connect to Azure from an identity perspective. So that's the right answer. And then we have last question. um, During deployment, what is the purpose of Kubernetes creating a new container while the old one is still running? So this is a tricky one, in fact, because sometimes you avoid downtime is correct. You are also thinking about scaling up or scaling out or redundancy. So what are your thoughts, Mela, on this?
Well, we can think about a bit what we were discussing today, the fact that we can, run another workflow by using GitHub Actions. So maybe it can be related to that. Why exactly doing it in the same time? What is happening in there? I'm curious also about the answer that we are going to get.
Yep. So it's avoid downtime. It's basically to because we are, as we showed, right. One of the pod was running when the other pod was not yet ready. So the other pod is running. The old pod, which is there, it is running, and the new pod, which is being created with the latest code, it's still, it's been created, but it's waiting for to become ready to accept traffic, right? So that is the readiness probe, which we discussed in previous sessions as well. So we have set it up in such a way so that the old one goes off and the new one comes in. So that is the one of the features of any orchestrator. The Kubernetes specifically is one of the basic feature to be used. So yeah, so we have come to an end to the questions part, and let's just summarize what we did. So basically, we created GitHub Actions uh, to be used with container registry, Azure Container Registry, from authentication perspective. So it required a couple of information to be added into the GitHub repo. We will go to the settings and we added it into the security part of it, and then we made a couple of changes to the code, and we built the image, and we deployed that into the microservices, and and basically we built that and stored it in the container registry. And here we go, what we did. So basically, we also went ahead and deployed it in the Kubernetes cluster, and we saw Helm chart, how it behaves from creating a new deployment and also reverting the deployments. Um, so make sure that you remove all the service principles and other things whenever you created something. That is what it means, and these are the things you can do, how to remove and other things specifically. And yep. So this is the learn module which we executed today, and make sure you go back and execute it. It's pretty interesting. And check out the magic script. The magic script is pretty amazing. And I was really enjoying looking at that magic script and playing around with it. So basically, it's an interesting one. And then to execute this module with from a GitHub Actions perspective, there is a QR code as well. So please pick up the QR code as well if you looking at QR code. And yeah, so Mahela, did you watch the whole series?
Yes, I think it was a very nicely linked series, so I'll definitely recommend to just rewatch the uh, all the sessions that you can find on the website. You can just look exactly both go through the module by yourself, but also if you maybe need some guidance, some extra information on some areas, rewatch the whole series. It was a lot of fun.
Perfect. Yes, and that's the link, and that's the QR code as well, and you can, you know, use the link or the QR code to watch the series as well. It's a amazing series, and obviously it has learn modules linked to it. So while watching it, you can also do it as well. Cool. I think that's pretty much today's agenda.
Yep.
Thank
Nice being with
thank
you.
you, Mahela.
Thank you.
Yeah, same
Thank you.
here. Thank you, Mahela, for this wonderful session. Thanks everyone for joining us. Thank you very much. Please do watch the whole series again.
See you.